which is this situation. You have two different metals somehow perfectly bonded together. You really cannot do surface welding of metals. Surface welding means that, seam welding, you put the metals like that, you seam weld around it. Or spot welding, dot, 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 dot. Theoretically, we should be able to do surface welding, but it cannot be done. We put adhesive there, or some kind of adhesive. It's not a weld anymore, okay? But we still call it. So these are perfectly bonded. Perfectly bonded means that they're fastened together, okay? Now, one end of it is clamped, and we take the structure and raise the temperature by 400 degrees. Put it in the oven. Put this thing in the oven. One end of it is fixed. Maybe attach it to something really heavy and then put it in the oven. Okay, so the question is, what will happen to this thing? It's called a thermostat, actually. This is the mechanism behind the thermostat. Because what happens is that it moves one way and establishes contact with another piece. The current goes through it, so that becomes a thermostat. But tell me, how is this going to, if you put this thing in the oven, what's going to happen? What does that mean? So, bends, right? You're saying it bends. The question is, does it bend up or does it bend down? You're saying bend down? Yeah. You look at that bend down, okay? Any other suggestions? You're saying it bends down? And now we don't know, let's find out. Let's find out. What does it have to do with? Coefficient of thermal expansions are different, okay? Aluminum is more, but we don't know what you're saying is right or not. We'll find out, okay? Now, this problem, by the way, does have a plane of symmetry, so I don't have to do the whole thing. I can just cut it through the length, not that, don't separate the two. Through the length, but in the book, this is done, but without any plane of symmetry. I'm going to cut it. I'm going to cut it. So let's go ahead and make it. Yeah. Product. Insert the top piece. Top piece is aluminum, so insert new part in there. I'll call it top. I'll call it aluminum. Properties. Okay, maybe top aluminum. How about that? Top aluminum. Okay, good. Let's make it. Nothing can be easier than that. So on that horizontal plane, I will sketch. You have a choice of making half of the piece and pad it, or you can make the whole piece and cut it. It's entirely up to you. Split it. So I'll do half of it. You understand what I'm saying? You don't have to make the whole thing and then cut it with a plane. If you want, you can make half of it because you know that you're going to be cutting it anyways. So this is 10 inches. I believe this thing was 0.5. What was it? Was it 0.5? 0.5? Maybe that was not 10 because that figure 6. That was 6. This guy was 6. It just didn't look the same as the other guy. 6. That's better. Okay, exit. Now I'm going to pad it up by half an inch. Yes. Because it bends. Okay. If both ends were fixed, the second plane of symmetry is in the middle. Okay. Yes. Well, if it's fixed, it won't go anywhere on both sides. It bends in the middle. It goes like this. It goes like this or it goes up, depending on how things. So we pad it up by 0.5. That was the thickness of that top strip. And we're going to put, actually it was, what was this? 0.25. I know these things don't look right. 0.25. 0.25. And we say, okay. All right. So we put aluminum properties on it. So Apply material. We are in part design. We have to be in part design if you're going to put material on part. Okay. So aluminum on the top. We say okay, and we close it. Now we're going to go to the product and insert our second piece, bottom steel. So insert a new part. Let's change the name. Right-click properties. Part number, part name, bottom, bot, steel, say okay. So let's make it. On that bottom, on that plane where we drew the aluminum piece, we draw. Can you tell me a fast way of actually making that bottom piece? Project it. Project this piece. It's going to be right there. You can see that. Right there. And then we're going to exit and pad it in the opposite direction. Okay, reverse direction, 0.25. And this is going to be made out of steel. So apply material on it. Metal, steel on that part, and we say okay. I like to change the color also. No reason, particular reason. I'm going to make it red, but I caution you that red is not a good idea because sometimes when things don't update or whatever, it becomes red. But sorry. Okay, so that's it. So let's go ahead and generative structure analysis. Catia sees two parts, immediately it meshes it. And these are gigantic elements through the thickness when you think about it. So let me make this thing a little bit more respectable. Maybe what is up here? Maybe 0.1 for the top one and 0.1 for the bottom one. 0.1. At some point, somebody is going to ask you, what is that sag there? We'll worry about that later. The size of the element, you understand. Sag, let's not worry about right now. Now, this will, we can run it, there's no problem, except that just be aware of the fact that you need a fine mesh at the interface because material properties are different. Stresses are going to be changing rapidly at the bottom and the top pieces, so this is not going to do it, but we're not going to worry about that. Okay, so what else do we have? We have these ends clamped. These ends clamped. Okay. Don't forget the surface slider because you cut this thing either on this side or that side because it really doesn't matter to us. This piece and the bottom piece. Okay. All right. Now, we want to put this thing in the oven because what makes this thing move then is the load is coming from thermal effect. Okay. So whatever you're trying to do, look in the load. Whatever. And if you look at the loads, you see this colorful thing. I'm sure you're familiar with this kind of a icon, temperature variation. Remember that? Or I don't know. You click on it, and it says, okay, you want one of these parts to be subjected to temperature difference. Okay, pick it. Well, I'm going to pick it right here. That's the top one. And as soon as you do that, it puts a T up there. So that top piece is going to have a temperature effect associated with it. And you put that number there. Temperature rise. That is 400 degrees Fahrenheit. Okay? Now, rise from what though? That's the problem. Because these coefficients of thermal expansion that you find in tables, they are at a particular temperature. Okay, whatever that temperature is. For example, if you looked in a book and you found aluminum has this temperature coefficient of thermal expansion at room temperature, for example, 80, just hypothetically, you have to tell the software that that number alpha that you're giving it, or it's in the database, is at that room temperature, because we don't know what that coefficient of thermal expansion is At what room temperature? It's probably 72, 75, something like that. So watch this. I'm going to close that. I'm going to close that. And as soon as we did temperature, something popped up in this line. This environment, you have never seen it before. But as soon as you did temperature, it popped up. And you click on it, it says initial temperature, room temperature. So if my initial temperature, as described in here, is temperature rise of 400, above the room temperature of 75, you got to change that number to 75, okay? So 75. By the way, I have changed my unit so that it's in degrees Fahrenheit. If it's in degrees Kelvin, if you haven't changed your units, it's going to be in degrees Kelvin. So you can type F, but it's going to convert it to Kelvin. So that's fine. And oh, I wanted to do the bottom one too. The bottom goes in the oven too. So let's go to this thing. I can do it again, or I can go there to load. Double click on it. I forgot to select the bottom one. So two bodies, put in the oven, raised by 400 degrees from whatever the initial temperature was, room temperature. Okay, so let's run it. Don't worry about that. So I'm going to plot the deformation for you. Displacement. How about displacement? Wait a minute. I'll do it from here. And this is pretty much where my system crashed in the morning. Oh yeah. I don't want to do this again. That's exactly where it crashed last time. But let me destroy it. Okay, right there. Can you see what's going on here? Didn't you say it's going to bend? Well, look at what happened. That top piece just moved out. The bottom piece just moved out. So why is this happening? Yeah. You have to say that these are perfectly fastened. We didn't do that. It's just two pieces that are expanding in space. It goes like that, it goes like that. Okay? So we deactivate this plot. We deactivate this and go and create our connections. Connections hasn't crashed yet. So let me hide this. For the first component, select the top face of the, in this case, steel. For the second component, the bottom piece of the aluminum. And this is going to be perfectly bonded, means it's going to be fastened. If you make contact, they slide on top of each other. Unless you go and put a coefficient of friction and say don't fool around with it and stuff like that, or there's a check mark there, no sliding, don't do it. Okay, so let's go here. This is the thing that I created. This is going to be fastened. This is the connection that I created, and it's going to be fastened. So let's look at this for the fasten. Face connections. By the way, you see, when you look at the connection properties, there's two toolbars that we're going to be using in this course. These are the two. Face that we have used it several times. Distance, we're going to be using it extensively next week. But these last two, which are welding, we're not going to do anything with it. Okay? And so we're going to make it fastened on there. And it puts the fastener sign here. And for those of you who have been paying attention to this fastener that shows up on problems that we have done so far, pretty much all the times that we have done it, there was a big box and the fastener was inside it. Or there was a big box and the contact thing was inside it. Or the big box where they prick, maybe shrink fit. I said, don't rely on that big box. There is no big box there. It depends on your connection, what you're doing to what. Here I did a surface to surface, and this is how it came out. Do not count on a big box and the fastener inside of it. Okay, let's do a run. Okay, let's look at the bending. You said down, right? Anybody up? You go up. One up, one down. Down. Because the aluminum wants to expand more. The aluminum wants to expand more. The steel says, no way, you're going to go with me. So it has to go down. Okay, otherwise it won't happen. Now, a couple of things here. Notice that I have generated two different plots here. As a matter of fact, let me also do one for deformation. So I've generated three plots. We'll see. Every time you generate a new plot, whatever is already there is going to get deactivated. Now, if you want to put these things side by side, and I'll tell you why I'm asking this, you have to activate the stuff that you want to put side by side. If you want to put all three of them side by side, no problem. Activate all of them. And we're doing it. Okay, good. And the other one? They're all going to be sitting on top of each other. So if you want to put them side by side, you go okay, you go here, you see, when you have an animation, I mean, the fifth one, the second one from the right, it looks like two things next to each other. So that's side-by-side contours. That's what it means. You click on it, it says, okay, in what direction do you want to put these side by side? In the X direction or Y direction or Z? Let's say you want to lay it in the X direction, like this. X. Let's say how far apart do you want them to be? So let's make them, I don't know, 3 inches apart. It says 8, so I'll make it 3. And say, okay, 3. This is struggling. My computer is struggling. So if you turn this thing around, maybe I laid it in the wrong direction. Or did I say X? That's what this. I should have said Y, because X is going to be, they're going to run into each other. That's what happened. So I should have said Y. It's going to be nice next to each other. Okay, so see that was a bad idea. They're there, but it's really not what I want. Let me try it again. I have a reason that I'm telling you this. This, by the way, this issue of going into coma has something to do with that recorder. Okay, it's not. These are Mickey Mouse problems. They should not matter. Listen, I'm really sorry. Every time I try to rotate, it goes to coma. So it allows you to put stuff next to each other. Okay, 3 plus next to each other, contour graphs. Because in the past, I have done it. I ask you to generate these 3 contours on the screen during your test. And how can I verify that actually you have done it? Because this thing goes away as soon as you do this thing, it goes away. I say, take a screen capture of what you see on the screen, save it as a PDF or a JPEG, and attach means dump it wherever you're supposed to put the rest of the stuff. You should be able to do it. I'm not suggesting you will or I won't. But anyway, and this, this is going to coma right now.